Okay, welcome back to trigonometry. So let's see here. We were talking about trigonometric ratios last time, and one of those things to remember that it is SOHCAHTOA. Okay, sine is opposite over adjacent. So if you remember this, it's going to be this sine is going to be the opposite over adjacent. So we'll say sine A, we'll call that A. We'll have a different triangle, we'll call that B. We'll say, okay, that's going to be adjacent over hypotenuse. So that's going to be adjacent. Okay, so it's opposite over hypotenuse. Cosine is adjacent over the hypotenuse. And of course, the tangent is going to be, tangent C, okay, is just going to be the opposite over the adjacent. And those are the pieces that we're looking for, opposite over adjacent. So just going through and remembering how to do that and writing that down about a million times so you never forget it, you'll know. Or you could watch that lady in California, you'll be traumatized, you'll never forget SOHCAHTOA ever again. But again, I warn you, don't watch that. It's not for the faint of heart. Okay, moving on. Remembering also that cosecant, okay, is going to be hypotenuse over opposite. It's just 1 over the sine. The secant, okay, is opposite over adjacent. And of course, the cotangent is going to be the adjacent over the opposite. They are just 1 over the original functions. So these are called reciprocal values. The other thing we can do about this is we know that the sine of going to be the opposite over the hypotenuse. I'm going to use the same angle. My cosine is going to be my adjacent over my hypotenuse. Now, if I divide these two together, we have sine divided by cosine, opposite over hypotenuse divided by adjacent over hypotenuse. Now, I remember that when we are in intermediate algebra, we learned about compound fractions, which are fractions stacked on top of other fractions. Delightful, I know. So what we're going to do is we're going to multiply top and bottom by 1. We're just going to multiply by the hypotenuse here. Now, this is going to cancel out our hypotenuse on both the sides here, and we end up with opposite, this hypotenuse is canceled, over adjacent, which was the tangent of this angle. Notice I always give the trigonometric function an argument. It's one of those things I'm trying to be really careful about because when you're going fast, it's real easy to forget them. Don't go fast on your exams. If you forget the argument, your calculus teacher will come down on you like an anvil. It will hurt. Okay, so try to get in the habit of always writing this argument, even when you're going fast, so that you don't forget to do it later on. Okay, you don't want your calculus teacher thinking that you didn't know that you didn't do well in trig. Okay, so this is a relationship you're going to have to remember for the rest of your life. Now, if your teacher says to you that you must memorize all of the reference angles, all of the easy angles, I'm going to show you an easy way to do that. So we're going to write down the angle here. So we're going to say theta. And here I'm going to make a little table of my sines. I'm going to make a little table of my cosines. And we're just going to write down the angles here. So we have 0, we have pi over 6, pi over 4, pi over 3, and pi over 2. All right. There we go, pi over 2. Now, just because I know we're still learning this, this was 0 degrees. This was 30 degrees. This is 45 degrees. This is 60 degrees, and this is 90 degrees, okay? So again, it takes everybody a couple of weeks to learn to go between radians and degrees. The more you do it, the easier it gets, but don't be too hard on yourself because it takes some time. Now, 0 degrees. Let me draw a little triangle here for 0 degrees. So we're going to draw a triangle. Okay, so here's my A. And then we've got a hypotenuse. We're going to say it's a unit hypotenuse. It's just 1. And then what I'm going to do is I'm going to take this triangle. I want opposite. We're going to try to figure out the sine of A here. We want our opposite over our hypotenuse. So something over 1. Now what I'm going to do is I'm going to shrink this triangle down. I'm just trying to draw this triangle down. I'm going to sit on this triangle down here so that this guy comes all the way down here and kind of closes in. So we end up with a triangle. It's called a degenerate triangle. It's not out on the street smoking cigarettes. It's a triangle that's collapsed. Okay, so what we're going to do is we're going to look at my opposite side here, which is effectively 0, and my hypotenuse didn't change. It's still 1. So my sine of 0 degrees is just going to be 0. Going back, let me make that look like a 0 rather than a 6. Okay, going back to yesterday when we talked about the basic triangles that we had to go deal with. I'm not going to do them again, but we ended up with the sine of 30 degrees, sine of pi over 6, that was 1 over 2. When we had sine of 45 degrees, that was the square root of 2 over 2 after we rationalized the denominator. 60 degrees, go back to yesterday, we had square root of 3 over 2. And then, of course, we have the sine of 90 degrees. I'm going to do the same kind of a thing with the triangle here. I'm going to say sine of A. We're going to draw a little triangle. Okay, we still have a hypotenuse of 1. Here is our opposite side. Here's our adjacent side. All right, and what I'm going to do, is our coordinate axis here. Okay, I'm going to take this triangle and I'm going to squeeze it in the other direction. I'm going to push it, smush it together so that we're pretty much dealing with just this one triangle that's pretty much the opposite side is the hypotenuse, right? So if I squish it together, the opposite is the hypotenuse, and we end up with a 1. Well, this is a lot of random looking kind of a problems, and that's hard to memorize. Okay, so what I'm going to do is I'm going to say, well, there's a lot of 2's here. Is there any way for me to say turn 1 into something that looks like a 2? How about we say 1 is actually equal to 2 over 2? Okay, that makes sense. That's still 1. And then we could say this is going to be 0 over 2. That's still 0. And then there's some square roots in here. So what I'm going to do is I'm going to make it even easier. We're going to make a pattern. So I want the square root of 0, which is still 0, divided by 2. Square root of 1, which is still 1, divided by 2. Square root of 2 over 2. Square root of 3 over 2. And then 2, how can we write 2 as a square root? How about square root of 4 over 2? So in order to remember your signs, it's just going to be square root of 0 over 2, square root of 1 over 2, square root of 2 over 2, etc., until we get the whole thing down. Cosine just works backwards, okay? So cosine is going to be square root of 2 over 2, square root of 3 over 2, square root of 2 over 2, square root of 1 over 2, and the square root of none over 2. And that is our cosine. So if you have to memorize these pieces, write down this little table and you'll be all set. Like, well, what about tangent? Like, that's why I showed you tangent. So tangent of this angle is going to be sine over cosine. It's going to be 0 over 1, okay, which is just 1. Okay, here we have 1/2 divided by, remember, like in 4th grade, you learned about the division symbol like this, square root of 3 over 2. This is going to be 1/2. Remember what we do with divisions, with fraction divisions, we say invert and multiply. So we have times 2 over the square root of 3. The 2's cancel. We get 1 over the square root of 3, which was equal to the square root of 3 over 3. Remember, going back to rationalizing our denominators that way. Square root of 2 over 2 divided by the square root of 2 over 2. I hope that's 1. Okay, I hope you can see that one. And then we have the square root of 3 over 2 divided by, let's see, 1/2. So again, we say invert and multiply, so square root of 3 times 2 over 1, those cancel, and we end up with the square root of 3. Now, here's a problem, because the tangent of 90 degrees, we have 1 divided by 0. That's not a fun number. We don't like to do that. Dividing by 0 is not very fun. That's undefined. You'll learn a little bit later when we start graphing it what that actually is going to look like. But right now, it's undefined, and that's all we're going to do with that. Okay, so trying to remember, if you had to memorize these, it does take you a little bit of work to get the tangents, but writing down the sine and the cosine, by the way, when I took trig, they did not show me this little trick. So you just had to memorize the whole thing. It was just like a giant mess of like, oh, these numbers don't make any sense. So I'm showing you because I would not ask you guys to do this because I'm not going to take away your calculators, but you might get some teacher someday somewhere that says, oh, you should have these memorized. There's a way to memorize them. Okay, so you don't have to go through the pain of trying to memorize these things in a bad way. There's a pattern, use the pattern. Okay, one of the things we use trigonometry for is we use it for word problems. So we have a guy wire. This is a Dutch term that pretty much is a wire that is attached to a mast in order to give it some support. Okay, so it supports a vertical tower. The wire makes an angle with 41 degrees to the ground. How far from the base of the tower is the anchor point of the wire? Let's draw a picture. Because it's a word problem, we're going to draw pictures. We're going to draw a little mast here. Okay, and we're going to have a wire. You can draw it on either side. It doesn't matter. Okay, We'll draw a little bit of the ground here, and we're going to say this is 18 meters long, okay? And we know that this angle here is 41 degrees. They want to know how far how far you are from the base of the tower, okay? So looking at this from a triangle, right? If I'm looking at this angle, here's my opposite side, which I have no idea. Okay, we don't need to know that. They want to know the adjacent side, and we're given a hypotenuse. What trigonometric ratio is going to relate the hypotenuse and the adjacent side to the angle? You know, that's cosine. So we're going to say that my cosine of this angle is equal to my adjacent side over my hypotenuse. I want the adjacent side. This is just a three variable equation, just like D equals RT, F equals MA. You've dealt with many of these before. You just go ahead and solve for the one that you don't know. I need to know the adjacent side, so this is going to be the hypotenuse, which is multiplying on the other side, times the cosine of theta is equal to the adjacent side. Now, this is the cosine of 41 degrees. I have no idea what the cosine of 41 degrees is. We have to use a calculator, and you're going to be expected to do that in order to figure out this problem here. So we're going to say this is 18, that was my hypotenuse, times cosine 41 degrees, and we're going to say that's my adjacent side. The units we're going to end up with is going to be in meters. Okay, so we'll go ahead and take out our calculator here. So let's go ahead and see we have this. So we're just going to say 18 times cosine. Where's cosine? There we go. Of 41. Actually, I'm going to do one thing before I type this guy all the way in. We're going to go to mode so I can go ahead and make sure that we are in degrees. All right. When I teach calculus 2, because usually you're taking physics 1 and calculus 2 at the same time, the sign on the door is like, don't forget to change your calculators from degrees to radians, just because that's the way it has to go. So we'll quit out of this. Okay, so just make sure you're in radian mode or you're in degree mode so it actually knows that you're talking about degrees. Okay, and we ended up with 13.58, and we should probably have express your answer to two decimal places kind of a thing here. So we would just say that 13.58 meters, because that's kind of that's kind of answer they're going to want. Okay. So that's kind of how you do those kinds of problems. We have a few more. Okay. And it's important to be able to solve these problems. This is the whole point of being able to do this. Okay. A person stands 40 feet from the base of a tree. Okay. So we have a tree here. Okay. Let's see. They are standing 40 feet from this thing. They know that the angle of elevation to the tree is 52 degrees. So we're going to draw a little picture here. Okay. Most of the textbooks actually come with a picture with you. Okay. So we know that this is 40 feet. We want to know what the height of the tree is. If I'm looking at this triangle, we have an opposite adjacent side. I don't care about the hypotenuse. I want to know opposite adjacent. So what trigonometric ratio relates the opposite and the adjacent with the angle? And you're like, oh, tangent does that. So we're going to say that tangent of theta is equal to my opposite over my adjacent. And then we'll go ahead and say, well, I know what the adjacent side is. I want to know the opposite. So we're going to say we have the adjacent side. So that's going to be 40 times my tangent of 52 degrees. And then we're just go ahead and calculate that out. And again, I'm just going to double check to make sure I'm still in radian, I'm still in degrees. I am. And that's all you pretty much have to do with this thing. So we have to type it in. We have 40 times the tangent of 52. There we go, times tangent of 52 degrees. And you don't have to put the end parentheses on there, but you can if you'd like. And we say, okay, this is going to be 51.197, I believe. Again, we'll round this to two decimal places. So we'll say this is going to be 51.20 degrees. 51.20 feet is the height of this tree. Okay, so there we go. Okay, so that's how we're doing stuff like this. Okay, you might say, what about the secant? I don't have a button for secant. Like, no, you don't. And typically, you don't. They don't give you word problems that make you use the secant. If you do, you have to turn it into a 1 over cosine in order to use your secant. So this is a wheelchair ramp. It's 12 feet long. It makes an angle of 6 degrees with the ground. So here we have our angle here. We have 12 feet long here. We know that this is 6 degrees, not 66. And we're going to say, what's the vertical rise? They want to know what this piece is. They also want to know how horizontally how that piece goes. So this is a two-part problem. There should be an A and a B here. So all we're going to do is say, okay, what about the vertical? Well, again, we have an opposite that we need. We have a hypotenuse, but we need the opposite. So we're going to say sine of 6 degrees is equal to my opposite over my hypotenuse. They know the hypotenuse, that was 12. So we're going to say 12 times sine of 6 degrees. That equals my opposite. That's the total rise there. I'm going to go ahead and do part B as well right now. Before I calculate this, we're going to say, okay, um, for the length of this thing, right, the horizontal value, that's going to be cosine because that's the adjacent side. So we're going to say cosine of 6 degrees is equal to the adjacent over the hypotenuse. Same kind of arithmetic. So we have 12 times cosine of 6 degrees is equal to my adjacent. And we're just going to go ahead and type this into our calculator. So we're going to say 12 times sine. Where is my sine of 6 degrees here? Boom, boom, boom. And there we go. And that we ended up with a total height of, again, we'll go with two decimal places, 1.25. And then what are we in here? We're in feet. We're in feet. Okay, so it's 1.25 feet up above. Okay, so we'll go ahead and we'll look at this for cosine. We'll say this is 12 times my cosine of 6 degrees. And then we'll go ahead and do that. We end up with 11.9 something, 11.93. Okay, because that's usually the kind of problem that you're going to be dealing with this one. All right. We have a couple more. So we have an airplane that climbs at an angle of 9 degrees above the horizontal. After traveling 3.5 kilometers along its flight path, how high is the airplane? So here we have a little, notice I'm always drawing the picture in order to sort this thing out. Okay, so here's our airplane. We have a little 9 degrees here along the flight path. So this is 3.5 kilometers. The airplane thinks it's going 3.5 kilometers. They want to know what is the altitude at this point. We're assuming that it stays on this 9 degrees. It's not changing anything. So again, we have a right triangle. Always make sure you have a right triangle. And then we're going to say that we have the sine of our elevation is equal to my opposite over my hypotenuse. And we'll go ahead and multiply by hypotenuse. So it's going to be 3.5 kilometers times my sine of 9 degrees. And that is equal to my opposite or my height. And we'll just go ahead and type that in. So we're going to say we need 3.5, okay, times sine of 9 degrees. All right, and I know I'm still in degrees, so everything should work out okay. And this thing is going to be 0.547. Let's see what we have here. 0.5475 kilometers. Okay, that's probably not the unit that they actually want. Again, they should really tell us, like, put your answer in meters or something. But let's go ahead and put it in meters because that tends to make more sense to me as far as like how far up and off the ground. Kilometers works if you're talking about a satellite. That's kilometers off the ground. But for an airplane, they probably want it in meters. So we're going to say we have 0.5475 kms here. How many kilometers are in a meter? So we know that there are 1,000 meters to a kilometer. So all we're going to do is we're just going to multiply this thing by 1,000. So we're just going to move the decimal place over 3 points. So we're going to say, okay, we need 1, 2, 3. So we are 547.5 meters off the ground. All right, and that's kind of how you're going to be doing this. All right, so let's see here. Let's see. Flagpole cast a shadow that is 22 feet long, or 22 meters long, rather, on level ground. The angle of the sun, there's something you can do that called an astrolabe in order to calculate those angles. But here is our flagpole, right? Here's the shadow. Here's 22 meters. Okay, and my angle of elevation here is 37. How about 37, not 73? Is 37 degrees here. Okay. So it must be early in the morning or late at night, or in the evening rather. And they want to know what's going on here. This is 22. Okay, how tall is the flagpole? So here we have an opposite, we have an adjacent, we have an angle. We don't care about the hypotenuse, we don't care about this angle here. But opposite and adjacent and an angle, we're going to say that's tangent. So the tangent of my angle is equal to the opposite over my adjacent. I really want the opposite side. So we're going to say the adjacent side, that's the 22 meters, times my tangent of 37 degrees, and that is equal to, and we'll go ahead and type that in here. So we're going to say we have 22 times tangent, tangent of 37 degrees. Okay, and again, make sure you're in the right mode because radian mode is going to be different. Word problems are usually given to you in degrees. Okay, you can go ahead and deal with that. But that's going to be 16.57. We'll call it 16.58 meters. That's the height of our flagpole there. Okay, and that's pretty much how we do this. Okay, I think there's one more, but oldie but a goodie. 15-foot ladder leans against a vertical wall. Again, we're drawing a picture. Okay. It makes an angle of 68 degrees. We know that the ladder is 15 feet tall. They want to know how high up can we go? Okay, so we're looking at this. We need opposite, we have a hypotenuse. So we're going to say sine, right? That's the one that goes with opposite and hypotenuse. So the sine of 68 degrees is equal to my opposite side divided by my hypotenuse. We know the hypotenuse is 15, so we're going to say this is 15 times sine of 68 degrees. All right, so we can go ahead and do that. So we just go through our calculator again. 15 times sine of 68 degrees. 68 degrees. We'll go ahead and do that. We'll say, okay, that's 13.9 something. Say 13.91 feet. Okay, and that would be our answer for that. Again, notice we drew a picture. We write down the right units when we're done. We have it to the correct decimals that we're done. These are all things that you should be practicing and making sure that when you type these things out and when you write down your problem, that you're dotting all of your I's and crossing all of your T's and making sure that it all looks very nice and professional so that people, when you do this problem, people are like, you don't know trig. You say, yes, I do know trig. Look, I have perfect work. I'm all good with all of this. Okay, so you want to do that just to make sure that people know that you know what you're talking about. All right. So I think that's a good kind of follow-up to our first lecture about trigonometric ratios. We're going to talk about the unit circle next time. So I'm going to say thank you very much for watching the video, and we'll see you next time.